In this video, I'm going to go over assignment number 7, questions from Regents Physics. Let's get it started. Problem number 1. Here's the problem number 1. Mr. Barry is trying to stop the car. In order to stop the cars, he has to apply force. He has to apply force opposite to the motion of the car. So there would be a negative acceleration. So we expect a negative force. Negative force is because the acceleration would be negative, would be the opposite to the motion of the car. So let's see how we can do that. We can definitely use the v square. You can definitely use the vf square is equal to vi square plus 2ad. Alright, vf square is 0 is because Mr. Barry is trying to stop the car. He is trying to stop the car. He's trying to stop the car. So the vf square is 0. So 0 is equal to vi. So make sure you understand that 100 km per hour is 28 meter per second. So 28 square plus 2. A is not given. A is you need to find the acceleration. D is given. D is 55. So acceleration is negative 28 square over 110. So acceleration is negative 7.1 meter per second square. So now force. Force is equal to ma. So force is, the Tesla is 1,500 kilogram times acceleration is negative 7.1. Alright, so that is negative 10650 Newton. Then how much force he has to apply to stop this car. Alright, so that's problem number 1 from assignment 7. Now we're going to take a look at problem number 2. So let's tackle problem number 2 first. So 10 kilogram of gravity. Okay, so frictionless, which make our life a little easier. So let's see what's going on. So the box is 10 kilogram. The box is on the table. The FG is 98 Newton. So we have to find the normal force. What is going on? Pushes down. Someone is pushing down. How much? 40 Newton. So then the normal force has to be bigger. How much bigger? 98 plus 40, which should be 138. Okay. And the second scenario is someone pulling the box upward with 40 Newton. So the same box, which is 10 kilogram. So the what is still same, 98 Newton. And some pulling it. So if someone pull it by, if someone pull the box by 40 Newton upward, what would be the normal force? The normal force would be 98 minus 40. That should be 98 minus 40. That should be 98 minus 40. That should be 58. So 58 Newton. Alright, so the answer to the question number 2 is 138 Newton and 58 Newton. Now we're going to take a look at question number 3. Question number 3. Alright, so a person is moving down in the elevator, standing on a step. So what is going on? So the person is, well, you know that when elevator accelerating down, the person should feel lighter. You know that. So it's a conceptual problem. Now I want to give you more understanding by finding the person weight. The weight would be same, 81 times 10, 810 Newton. But the normal force would be smaller. How smaller it is? Let's see, mg minus a. So Fn would be m is 81, g is 10, a is 0.1. So let's do it differently. G minus 0.1 g. So 81.9 g. So 81.9 g. So let's see, 0.9 times 0.9 times. So 729. So Fn is 729 Newton. So Fn is 729 Newton means the scale will read about 73 kilogram. So scale will read, so Fn is 7 to 9 Newton, Fn is 7 to 9 Newton, and scale will read 72 kilogram. The person is 81 kilogram, so apparent weight loss is 8 kilograms. So the person will feel lighter. The person will feel lighter, of course. Problem number 4. A 10 kilogram box, again a 10 kilogram box. Let's make a room. 10 kilogram box. What is happening with 10 kilogram box? We have to find the weight. Weight would be 98 Newton, and we have to find the normal force. To find the normal force, we have to find the both component of the pulling force. 40 cosine 30 and 40 sine 30. 40 cosine 30 is 34.6, and this is 20 Newton. So this one is contributing to the normal force. So the normal force is 98 minus 20, which is 78 Newton. Okay. So now we're gonna go problem number 4. By a rope, we want to find the acceleration on the box. Find the acceleration to box number B. All right. So let's find the acceleration. All right. So we have two box, this box and this box. Let's draw the free body diagram. So let's say box 1 and box 2. Okay. So the box 1. How many forces? I see one force. I'm gonna call it FP. I see other force. I'm going to call it FT. All right. This box number 2. I see FT over here. So I'm going to call FT. All right. I don't see any force over there because it's frictionless. So I'm not going to write anything. So now I know that I have to use Newton's second law. MA. All right. A positive is because I'm pulling to the right. So how many forces I see? I have to report what I see. I'm going to write FP. I'm going to write minus FT because they are not in the same direction. All right. Now I have to do the other side. I have to report what I see. I see only one force, and that's what I report. M2A, and this is M1A. Make sure you do that. So I can replace this FT by this one. So let's do that. So FP minus FT is M2A is equal to M1A. So FP is equal to M1A plus M2A. So A is FP M1 plus M2. So A is FP is 40 Newton, M1 plus M2 is 12 plus 10. So 40 over 22. So 40 over 22 is 1.8. So acceleration is 1.8 Newton, and the answer is this. Okay, now we are down to last problem. So let's solve the last problem. Okay, here we have to find the measure physics error. So let's first find the measure physics error. What is going on in this problem? This problem, someone is crouching up. So someone is crouching up. Someone who is 81 kilogram, and someone is crouching up. When someone is crouching up, someone arrived the maximum height of 81 meters, 0.81 meters, 0.81 meters, and that's about it. That's about it. And the crouching, and we also know the crouching. The crouching happens 0.2 meter. That's the crouching time. Crouching down is 0.02 meter. Okay, so let's find the mistake. First, we have to find the velocity, the initial velocity of the person, which is 40 meter per second. Which is the initial velocity of the person is 4 meter per second, and I see is 4 meter per second square. So that's mistake number 1. So that's the mistake number 1. All right. So let's see the second solution. In the second solution, let's see what is going on. This acceleration takes place 0.8 meter. That's not true. The acceleration takes place when he is crouching up, and crouching up happens only 0.2 meter. So crouching up happens only 0.2 meter, not 0.8 meter. Not 0.8 meter. 0.2 meter. When he crouching up, due to acceleration at the upward direction, the person feel heavier is because the apparent weight gain, and that is happening 0.2 meter, not 0.8 meter. Okay, so that's mistake number 2. That's mistake number 2. So we found so far 2 mistakes. All right, let's see whether we can find any other mistake. So problem answer number 3, I see a mistake over here, and this is when the person jumping up. This is similar to Mr. Body is stand on a scale inside an elevator who is accelerating downward. Now, when the person crouching up, when the person crouching up, this is not similar to the elevator accelerating down. This is similar to elevator accelerating up. This is similar to elevator accelerating up. Accelerating up. Why? Because crouching up you feel heavier. Elevator up you feel heavier. You feel heavier because acceleration upward. You feel heavier because accelerating upward. You feel heavier is because net force is upward. You feel heavier is because net force is upward. You feel heavier is because apparent weight gain. You feel heavier apparent weight gain. So the crouching up is similar to the elevator accelerating up, not what I see over here accelerating down. So far I found 3 mistakes in this solution. It's important to solve the problem, but it's even more important to find debugging the solution, because debugging the solution is as important as solving the problem. Thank you.